Hello there and welcome to A2 Maths from June 2018, paper 2, and here we're looking at question 5, a iterative sequence question. So, the equation 2x cubed plus x squared minus 1 equals 0 has exactly one real root. Show that for this equation the Newton-Raphson formula can be written as this expression here. So, what we need to do then is we need to turn 2x cubed plus x squared minus 1 equals 0 into this expression here. I think this is one of the very rare occasions where I'd actually start from the answer and see how I might work myself back to the original question. So just from looking at the from looking at the answer that I want to turn it into, that's this thing here. I've just got rid of all the xn's on it, but obviously when you turn it into an iterative equation, it needs the n's on it, but for the moment, while I'm rearranging, it doesn't need the n's on it. And this is what it would look like without the ends on it. And I want to turn this into this. So I'm going to do a few steps going backwards to give me a bit of a clue as to what I might do with my equation. First thing I'll do is I'll probably multiply the denominator onto the other side. So 6x cubed plus 2x squared equals 4x cubed plus x squared plus 1. Okay, so does this look anything like what I've got here? Well, yeah, if I take away 4x cubed onto the other side, I get 2x cubed. If I take away x squared onto the other side, I'll get x squared. If I take away the 1 onto the left, I'll have minus 1, and then I'll have 0 left on the right-hand side. So I kind of need to do the reverse of what I was just talking through there to this expression here. The first thing I'll do is I'll add 1 onto the other side. So I have 2x cubed plus x squared equals 1. Okay, so I've got the 1 on the right hand side now. I need an x squared on the right hand side as well. So I'll add x squared onto the right hand side. So I'll have 2x cubed plus, well, if I'm adding something to one side, I need to do exactly the same on the other side if it's to remain equal. So I now have 2x cubed on the left equals x squared plus 1. I also need the final step to add 4x cubed onto the right hand side. And if I'm to make the equations the lines equivalent, I need to do the same thing to the left hand side. So I now have 6x cubed plus 2x squared equals 4x cubed plus x squared plus 1. Okay, so now how do I get it into this form here? Well, I'll now factorize out an x, so it's x bracket 6x squared plus 2x in brackets equals 4x cubed plus x squared plus 1, and then I'll divide by what's in the bracket, so x equals 4x cubed plus x squared plus 1 all over 6x squared plus 2x. Therefore, the iterative formula xn plus 1 is equal to 4xn cubed plus xn squared plus 1 over 6xn squared plus 2xn without the squared on it, so no, just xn. So there we are. We've shown that we can rearrange this equation here into this equation here, and I used the method of doing the calculation in reverse just to give myself a head start. Note that this doesn't involve keeping it in my answer. It was just for me to have a mental clue as to what I need to do in my answer. So this part here forms no part of my actual final answer. It's just helping me give myself a clue as to what I'm going to do next in the next couple of parts. Okay, so moving on to part B then, find the values of x2 and x3. So this part is actually super nice and easy. All we need to do is grab our calculator, plug in 1 as the and then press equals and have 1 as our answer, and then we can move on to the next part. What we'll then do is we'll write out this big long iterative formula here using the fraction button, but instead of xn we're going to use answer button. So what's it going to look like? It's going to look something like this. So for x2 we get 3/4. and we just need to press equals again to get the next answer, x3, which is 2/3. Okay, so there we are. That's all we needed to do for part B. It's just making sure that you know how to use your calculator using the answer button as the xn kind of value, or using answer as the algebraic equivalent of xn. Okay, so that's the answer to part B then. Moving on to part C, explain why for this question the Newton-Raphson method cannot be used for x1 equals 0. Well, for the Newton-Raphson method, if we have an equation f of x equals, we'll give it this thing here, 2x cubed plus x squared minus 1, then the Newton-Raphson method will give us f of x2, so x2 rather, equals x1 minus f of x1 over f dash of x1 rather, the differential goes on the bottom. I suppose when we use x1 equals 0, then when we differentiate this, so if we do f dash x, we're going to have 6x squared plus 2x, and if we do f dash of 0, which is what they're going to want us to do on the bottom, then we're going to get 0. So 0 will appear as on the denominator of the Newton-Raphson formula. Okay, so there we are. That's the answer to part C, and that's the answer to question 5. So that's 6 marks for question 5. That's all we need to do there. Let's now move on to question 6.